going to the next paper, which is written by a group of authors: Costin Busioc, Vlad, Dumitru, Stefan Trausan-Matu, Simina, Terian-Dan, Mihai, Dascalu, and Traian, Rebedea. So, and I understood that Costin Busioc will present. The paper is called "What are the latest fake news in Romanian politics? An automated analysis based on BERT language models." So it's an interesting paper. Please, Costin. Costin, it's one of our best master students, and it's a pleasure to hear it. No, please, Costin, you have the...
double checking that you can see my presentation and the sound.
Yes, everything is okay.
Perfect, thank you. Hello, my name is Costin, and today I'm going to offer the presentation on our paper, What are the latest fake news in Romanian politics? An automated analysis based on BERT language models. As the name suggests, our presentation will highlight details on the experiments we have performed while trying to analyze fake news in Romanian, while making use of language models such as BERT. We will start with a really short introduction on fake news in general, and we'll continue with a short introduction on BERT so that the presentation and if reading the paper, we'll have more context. And of course, continuing with the experiments and results we have obtained. With more and more access to the internet and the continued growth in sharing information across social media, fake news grows in volume as well and in spread in impact. Fake news is one of the most recent trends discussed across the globe, and it's understandable because of the consequences it generates by damaging societies, democratic institutions, and most importantly, misinforming people. Alongside these events, fake news became a popular topic among researchers as well. Multiple attempts on providing solutions to detect or flag such damaging articles as accurate as possible being discussed in papers, most of them using NLP and machine learning techniques. And while working with solutions that should perform automatic detections, a key factor in such work is having examples of annotated data in order to make the algorithm understand what would the difference be between true and false. And this is not an easy task because annually annotating data on tendentious subjects like fake news and being analyzed from an objective perspective is a difficult and time-consuming task. In order to point out some important contributions in literature that we discovered as interesting, we will have to mention PolitiFact, a website which publicly displays analysis on different statements mentioned by politicians and public persons. The team behind PolitiFact splits the selected statements into 6 categories based on their truth value: true, mostly false, false, and so on. They have a clear methodology behind the selection process, and the team behind PolitiFact explains their decision behind. A successful approach in automatically analyzing fake news was performed while building the LIAR dataset, consisting of a bit more than 12,000 statements collected from PolitiFact at the time of the work, designing NLP models for this case. Similar approaches would be the fake news challenge that relies on the emergent dataset and that tries to solve the clickbait task, designing models that are able to detect if the title and the content of an article are related in a way in order to combat the shiny titles with tendentious contents. And last but not least, Claimbuster is an initiative that tries to automatically detect important pieces to be analyzed from political discourses, and that relies on the past US presidential elections. This is an example of PolitiFact website, which is relevant as it connects most with our work. This is the reason why I presented all of those. PolitiFact, as I have already mentioned, displays different statements alongside their truth label with a dedicated page for interpreting each one of them. Now, switching to the actual language model used, we will talk about BERT. Bidirectional encoder representations from transformer is one of the current trending language models based on the demonstrated applicability in a wide variety of tasks. What BERT does different, as its name suggests, It analyzes text in a bidirectional way, left to right and right to left, compared to previous efforts that only took into account the one-way approach. This way, the model manages to better understand the connectivity between words and relationships that occur in a language using the underlying mechanism called attention. The actual value of BERT is the applicability of using already known information, improving it on a specific task or fine-tuning it. This is why there are many instances of BERT models that were already pre-trained on big data like Wikipedia. Then they can be fine-tuned on smaller data sets and tested on maybe even smaller ones. A similar approach has been used in our experiments as well, starting from raw BERT, a pre-trained BERT model for Romanian, because all our experiments rely on Romanian language only. And to dig a bit more on how BERT works in order to understand how our experiments were performed, what BERT actually does, it translates words, so pieces of understandable words, to vectors, pieces understandable by NLP models. The vectors are represented in a space based on the word's connection, and so they can be used in such tasks. And these vectors are generated based on two tasks: the masked language modeling task, in which the BERT model replaces some of the words with a special token called mask, and then tries to understand which of the words should have been there. And the second task is called next sentence prediction, in which the BERT model receives pairs of sentences. Some of them are in the order they are presented in the original document, and some of them are shuffled. And the BERT model tries to detect the correct order and to understand this connectivity. Performing the magic behind, the BERT outputs the vectorial representations of the vocabulary used in the work. Now, digging into the actual work performed in our paper, we will start by presenting the collation of data we have used, namely the Factual website. Factual is a fact-checking tool similar to PolitiFact, but which focuses on Romanian politics and general interest topics. Similar to PolitiFact, the editor's team behind the project is responsible for selecting statements and offering clear interpretations for them. And at the moment are approximately 1,000 statements on the website, compared to PolitiFact, where there are already more than 20,000. Each statement on the Factual website has a dedicated page split into sections, where relevant information is displayed and which we found useful in our work. Among the statement itself, we can identify the context, which is basically like a short summary of the event the statement was made about. And two particular sections, what to validate and validation, which are basically the research performed by the editors in order to validate the statement made by the specific author. We found this validation section particularly useful in our experiments because the statements alone are not enough to classify the text. And our objective is to show that having access to data that may confirm or deny a statement influences the computational interpretation of such texts. Particularly interesting when compared to PolitiFact, compared to PolitiFact, Factual offers a wider range of truth labels. For example, impossible to verify, truncated, outside the mandate, or during the mandate. But because of the limited samples of some of them, for example, only 5 statements for the impossible to verify category, we decided to perform a selection of the data and only preserve the 4 main categories: true, partially false, and false. So we ended up having 844 statements and their corresponding details, such as the validation context and all of that. Additionally, the statements are also already classified into several categories, such as politics, agriculture, or economics, which for our work were not used, but which may be useful for future work, as we will see. At this point, we made use of the BERT models, as I have already mentioned. BERT models can be used for classification tasks using 2 input texts, similar to the sentence prediction task. In our case, the two inputs would be the statement itself and the validation context. And due to the fact that the context may be too long, as their mean length is almost 2000 characters, and the Robert model is only trained to accept 512 tokens, we decided to limit our input to only pieces from the validation context, namely the first and the last paragraph. The decision behind is justified by the fact that we want to keep the statement as the central piece of the input. So that's why we decided not to limit the statement, but the context. From the initial set of statements, we have split it and kept 674 for the training step and 171 for the testing step. Because the data set is really limited inside, we have used the 5 cross validation step in order to use our hyperparameters for the models, because it would have been difficult in another way to simply guess how should the model look like. Our final model had the following structure. The BERT model is the starting point, expecting as input the statement and the validation context in pair. The output is then fed in through a dropout layer, a hidden layer, and the final dense layer with softmax activation layer. The softmax layer will output 4 values, namely the probabilities for the 4 classes we want to predict the value for: true, mostly false, and false. The biggest probability will then represent our model prediction for that particular statement.
Costin, excuse me, you have only 3 minutes, so please.
Yes. Thank you. Because of the unbalanced collection of data, we have performed most of our experiments using a class weighting factor for the proportion between the number of examples in each class and the number of examples in the most common class. And as we can see in the results table, the best result is obtained while using the unweighted factor. But this is because it only predicts well the 2 ends of the spectrum, true and false. However, the equivalent model that uses the weighting class factor obtains a balanced set of predictions with a much better F1 score. As in most of experiments, there are a list of limitations. I already have mentioned that the small data set size was the main drawback in such experiments. But we would also have to mention the topics diversity, because Factual is split into categories. And for example, the politics category, it's much more, is much bigger than the industry one, meaning that the context will be diversified as well, and the BERT model will find it difficult to understand them. The particular labels are a drawback as well, because our data set was reduced by almost 10% in size. And probably a big limitation would be the categories, true versus mostly true, because as we have seen, the model finds it difficult to understand these subjective interpretations. And if we would have been limited to only 2 true and false values, we would have obtained a good accuracy. To sum up on our paper, we have introduced Factual and some experiments that rely on the Robert model, some results that are comparable to the layered dataset, but with applicability on Romanian, and to understanding if the context, the validation context, helps while validating fake news statements. Some potential next steps in our vision would be to perform some cross-lingual experiments while using PolitiFact, and also design an information retrieval mechanism to obtain such validation context from different pieces of laws or trustful resources in order to automatically improve the model prediction without needing the interpretation from the Factual editors. Thank you for your attention, and I'm sorry for being late. I would be happy to respond to any questions, if any.
Thank you. You are not late, you are just in time. Okay, so we have 5 minutes for questions, comments. Thank you, Costin.
Can you tell us what exactly is the context for a statement? How big is it? Can you tell something about it?
So, for example, the context would represent the research work performed while defining if a statement is true or false. Let's say a politician makes a particular statement about a country's size, for example. The validation context would be either confirming or denying his statement with actual facts. For example, quoting pieces of data from laws or from trustful resources in order to confirm or deny the statement.
Okay, and in size is comparable to the statement.
It's much bigger. So the mean length for the validation context is about 2,000 characters, while the statements are somehow limited to maybe 100.
Thank you.
Thank you for the question.
Thank you. Other questions, please? If not, I will put one question. So you said as future work using some information retrieval techniques. What do you have in mind? What you are referring at?
For example, as Factual website focuses on Romanian local news, let's say, during their validation context, they also offer URLs to relevant pieces of data. For example, they offer references to the pieces of laws they use or the news article they inspired from. And maybe a relevant idea would be to crawl all these data. For example, crawl all the Romanian laws, all the news from trustful resources, all the information that are validated, and basically rely on such a big amount of data when collecting the validation context for a statement.
Okay, and so are you also having in mind to, for example, having some data about the authors of the news, some credibility of
that would be an interesting experiment as well, especially because most of the authors are activating in the political industry, and probably I don't know, like lots of news articles or things like that can be obtained for such public persons. So definitely.